The shape that a quadratic function has when you graph it is called a parabola. P-A-R-A-B-O-L-A. Parabola. Okay. Don't say it parabola because then it sounds like some disease in Africa. But it's parabola is what that is. And it looks like this. It's kind of a U-looking shape. Either opens upward, sometimes they open downward. When you get into like pre-cal and that sort of stuff, they can open sideways too. But most of ours, since we're dealing with functions, they have to open vertically out of that. So that's what they look like. Depending on the form of the function, we're going to be dealing with standard form first. Ax squared plus bx plus c. We've seen that. We've dealt with that quadratic formula. Factoring, we had that form as well. So we're pretty familiar with that form. The a, the number in front of x squared, decides which direction it's going to open. Okay. If a is positive, that means it's greater than 0. It opens up. So it looks like that. And it has a minimum. Okay, the minimum is that lowest point in there. So if it opens up, it's got a lowest point at that, at the vertex is what that's called. So that if A is positive, in every form, A is in there. B and C aren't always in there, but A is always there. No matter which form, if we're dealing with standard form, we go to intercept form, we go to vertex form. Whatever A is, if it's positive, it's going to open up and it's going to have a minimum. So that's always the rule for quadratics. If A is positive, it opens up, has a minimum. If A is negative, it'll open down, which is the frowny face style. And that point there at the top is called a what? Maximum. That'll be important for what we're doing today, but it'll be even more important when we talk about word problems because they'll ask us to maximize or minimize some situation. And anytime you see that, you're thinking, oh, it's talking about the vertex for that. Maximize or minimize is talking about a vertex when we're dealing with that. So that'll be handy when we go to the word problems for sure. All right, so let's talk about all the things we're going to find for a graph. So the graph of a quadratic and let's start in standard form. So f of x equals ax squared plus bx plus c. So if it's in standard form, there are 6 things that we're going to do to graph a quadratic. The very first thing we're going to do is find the equation for the axis of symmetry. The axis of symmetry is this imaginary line. We go up here to our little sketches of parabolas. There's this imaginary line that goes right down the middle of those parabolas. Actually goes through the point that's the vertex. And symmetry, if you've had geometry before, or even if you haven't, talk about symmetry, it's talking about taking a picture and folding it across this line, and it matches up perfectly. That's what a line of symmetry does. So that equation for the line of symmetry is what we're going to find there. It's an important thing as far as quadratics. Not every graph is symmetric, but every quadratic graph is. So that's why it's quite unique and important to that. There is a little formula that we can use if the equation is in standard form. That little formula is x equals negative b divided by 2a. Does that seem familiar? It should feel pretty familiar because it's kind of part of the quadratic formula out of that. You remember we had negative b plus or minus and then the discriminant stuff, and then it was all divided by 2a. Well, this is kind of part of that. It's where this is coming from out of that. So the axis equation for the axis of symmetry So if it's a quadratic function, it's going to be x equals negative b divided by 2a. We're just going to work that out and simplify that fraction if at all possible. Okay, so we'll do an example with this stuff in just a minute. But the second thing we're going to find is the vertex. And the vertex is an ordered pair. It's a point. The x value of the vertex is always the same as that number that was in the axis of symmetry. Always the same. So it's always going to be negative b over 2a. If we have an x value and an equation, how do we get the y value that goes with it? You just plug it in. So we're going to work out f of negative b over 2a, which just means plug that in and work out the number, get the y value. So I'm going to show you a little trick with your graphing calculator that can help you do that quickly and efficiently. We can also do it by hand, but I want to show you some tricks that your graphing calculator speeds you up on. Okay, so vertex is an ordered pair. Then we decide if that vertex is a maximum or minimum, and all of that depends on A. If A is positive, then it's going to be a minimum. If A is negative, it's going to be a maximum. So we're going to decide that. So minimum if A is positive, maximum if A is negative. Okay, we'll find the vertex, then we'll just state if it's a max or a min. Okay, that's what we're going to do with that. Again, that's going to come in really handy when we go to word problems on Wednesday and Thursday. All right, the next thing we're going to find are intercepts. X-intercepts and y-intercepts. X-intercepts are what we've been doing for the last week and a half, 2 weeks. Solving the equation. We set the equation ax squared plus bx plus c equal to 0. And then we solve it using one of the methods that we've talked about over the last 2 weeks. Okay, so we're going to either use quadratic formula, factoring. There might be some instances where we use square roots, or we might use complete the square. Probably not. We probably use quadratic formula most of the time if we want to do that. So x-intercepts, you're going to set the problem equal to 0 and solve it. Y-intercepts, if you're on the y-axis, what's your ordered pair look like? 0 something, right? So we're going to plug in a 0 for x. And if it's in standard form, and I plug a 0 in for x, what's the only thing that's left? C. So the shortcut is if it's in standard form, you automatically know the y-intercept is going to be C if it's in standard form. So that's one of the shortcuts from standard form, is that you can get the y-intercept by just looking at the number that's on the end. It's automatically that number. All right, so if it's in standard form. On the x-intercepts, we should have how many x-intercepts? Always 2. Hey.
Did everything right. I tried typing that thing wrong.
Now, did it let you change your password? Put that password in for me. Okay. Let's see if it's just a security thing. All right. Yeah, put your password in there again. Let's see if we can do it. All right, try again. See if that gets you in. You can sit right there and do it if you want to, yonder. All right, next thing that we're going to find is the table. And when you make your table, I want you to put the vertex in the middle. And we're going to put two values to the left and two values to the right on the x's. And then we'll work out the y values that go with that. Okay? Again? All right. Good deal. All right, so vertex goes in the center of your table. That's how I want the tables made when you do this stuff. And then number 6 is the graph. And we're going to draw those graphs as we do that. Okay, so those things are the 6 things that we're going to do to graph a quadratic. So kind of give you a heads up on the test. I may not ask for all 6 things. So you may
Hudson, report to the office. Hunter Hudson.
The idea is that you learn to do each individual part depending on what you needed for the problem, and not every word problem is going to need that stuff, but it all relates back to the graph. So let's look at some examples. Let's start with one in standard form. So f of x is equal to x squared plus 6x plus 9. Okay, so that's our quadratic. We're going to go through the steps of graphing that and finding all of those different pieces for that. So the first one is going to be the axis of symmetry. Remember the little formula is x equals negative b divided by 2a. So we're going to plug in the information that we know from our problem. Negative b would be negative 6. 2a would be 2 times 1. And we want to simplify that. So negative 6 divided by 2 times 1 would be negative 3. So the answer to the axis of symmetry is x equals negative 3. If you don't have the x equals, I will count it wrong. Because negative 3 is not an axis of symmetry. An axis of symmetry is a line, so it has to have an equation. So x equals has to be there. Okay, don't just give me a number. The good thing about that is because the next thing, I get a little shortcut because I already have half the vertex. I know the x value of the vertex is negative 3. And all I got to do is find the y value of that. So to find the y value of that, what do I do with negative 3? I just plug it into the problem. Now, if we do that by hand, we'll do that first, and then I'll show you how to set your calculator up to do this. So that'd be 9 minus 18 plus 9. It ends up being 0. So we get a vertex at negative 3, 0. Is that a maximum or a minimum? What was A? Positive 1. So if it's a positive, it's going to open up. So it's going to go this direction. So that'd be a minimum at the bottom. So this is a minimum. All right, I want to show you how you can use your graphing calculator to help you. It's going to help us on the table, and it can help us here as well. Okay. So with the graphing calculator, everybody grab your calculator and get it turned on. Instead of typing in the problem like that, we're going to go to the y equals menu and type in the equation that we have here. So hit y equals, go x squared plus 6x plus 9. All right. So make sure that you don't have other equations in there. So if you got stuff in like y2, y1, or y3 and all that stuff, scroll down through there just to make sure you don't have any other junk in there and delete it because it could cause errors. Also up there at the top, the plots 1, 2, and 3. If there's any of those that are darkened in, they look like that, press your up arrow to that, hit enter to turn it off. You should not have any of the plots 1, 2, or 3 darkened in. If yours are darkened in, you need to turn them off. Okay. Now, the next thing we want to do is set up our calculator so that we can type in any x value that I want and get the y value back to us. Okay. So the way we're going to do that is hit second and then the window button. Second window. Press the up arrow, get it blinking, and then press the up arrow, now it's blinking, hit enter. All right, and hit second window. It should be something like that. Everybody at this screen, everybody not at this screen. All right. It really doesn't matter what you have the table start or the delta table, the first 2 lines, doesn't matter what they have in them. It does. If yours is different, that's okay. You want to set them to 0 and 1, that's fine. But we want the independent to be set to ask. Independent is X. Okay, so independent is X, so we want to set that to ask. So if yours was set to auto, it would look like that. Press the arrow down, move it to ask, and hit enter. You want the dependent set to automatic. Okay, so auto on dependent, ask on independent. Okay, what this allows us to do is tell it which X values we want it to calculate. Okay, now hit Y equals. So you've typed in an equation, you've got it ready, your table should be ready to type into. Now we want to be able to type in some X values. So hit second and graph. You may have some X values in there, you may not. If you do, it's okay. If you don't, that's fine too. Okay. If there are X values already typed in there, that's fine. Now, you can't delete the ones that are already there without like just clearing the memory of the other thing, but you can type over them. Okay, it's not like the list where you can clear out a list. This is the table function. So we want to plug in the -3 and hit enter. That's the X value we were working with to find the vertex, and there it is. It punches out the Y value that we found by doing it by hand. Okay, this is going to be helpful when we go to do our table. We can get all of those values real quick with that. Okay. Did anybody have trouble getting it to do that? All right, good deal. Let's keep going. The third thing that we're going to find are the x-intercepts. I'm just going to go up here on the right and get the x-intercepts. So we have a quadratic equation, x squared plus 6x plus 9. We want to set it equal to 0 in order to solve it. And then we have options as far as how we solve it. We could do factoring. We could do quadratic formula. Either of those ways would work well. I'm looking at that and I'm thinking multiply to be 9, add to be 6. Factoring would be easy because I can get those numbers real quick. 9, 6 would be 3 and 3, right? So we'd have x plus 3 times x plus 3. So we got a repeated solution here. X plus 3 equals 0, is at -3. So our x-intercept is at -3, 0, and technically it's there twice. It's a repeated solution to that. Okay. Happens to be the same as our vertex, but that doesn't always happen. Okay, it just happens to be on this one. Okay. So we did factoring to solve that. If you'd done quadratic formula, you get the exact same answer out of that. Now, y-intercept is next. Y-intercept, you just plug a 0 in for x, or we know it's in standard form, so what would it be? 0, 9. The shortcut is that it's always C if it's in standard form. If it's not in standard form, you can't take that shortcut. Okay. Now we need to make our table. So when we go to make our table, we're going to put the vertex in the middle. So our vertex was -3, 0. And then we want 2 x values to the left of -2. So what's to the left of -2? Nope, that's to the right. To the left would be -4 and -5. So what I want to do now is take my calculator and plug in those x values in that table and get it to crank out the y values for me. If you don't have that calculator handy, then you plug these x values into the problem and work out what y is. Okay. So on my calculator, I'm just going to set up the -5, -4, -3, -2, -1. And it cranks out the y values that go right along with that. Eli. So then you don't have an equation in there. You're lying. You may have accident. You can if you want to. You just know these are the only five to worry about. The rest of them.
So you gotta have an equation in there.
You get that? Yes, that's right. Anybody else having an issue with that? Though their calculator not doing the right things. Okay. Once you've set your calculator to do that independent ask thing, you shouldn't have to reset it unless your calculator dies and it resets itself. Okay. All right. So we're going to write that as our table, and then we're going to graph it. So we got 4, 1, 0, 1, 4. So let's go graph that on a coordinate plane. So we got to draw it here, because at some point we've got to turn something in. We can't just turn in our calculator screen. So we're going to plot those points. So -5, +4, -4, +1, -3, 0. You see, we've got that parabola shape there. If we go to our calculator and hit graph, and then hit zoom 6 to put you back in the normal, the 10 by 10 window, you should see that same picture, just without the dots on it. I just hit graph on the calculator. It should look something like that. Should be vaguely familiar with doing this in the past, except for the calculator part. But nice, easy thing to do. Okay. Now, that axis of symmetry that we found, this is what that looks like. Because remember, x equals a number is a vertical line. That's where that would be. You don't have to draw it on your graph. Just know where it's at. Know that x equals -3 is that vertical line that's there. Okay. All right. Let's look at another one. Let's look at a different form this time. Let's look at intercept form. It sounds like a fancy thing, but it's something you're familiar with. Intercept form looks like this. A parentheses x minus m, x minus n. What's that look like? A quadratic that has been done what to? It's been factored. That's what it looks like. So you might, I'm bad to interchange intercept form and factored form. They're the same things. Okay, intercept form, factored form are the same things. Notice though that there's an A in the front of that. That A has the same power as the A that was in front of the x squared in the standard form. Okay, so since it's called intercept form, what do you think the easiest thing to find from that form is? The intercepts. Okay, the x-intercepts to be more specific about it. Okay, so intercept form, the x-intercepts are some of the easiest things to find out of that. So let's look at an example that's in intercept form. So f of x equals negative parentheses x plus 5, x minus 3. Okay, so here we have a negative in the front and then an x plus 5 and an x minus 3. We're still going to find all of these things. We're going to find the axis of symmetry. We're going to find the vertex. We're going to find the intercepts first, though. Because the form it's in, Makes it super easy to find the x-intercepts. The rule is you set the whole problem equal to 0, right? To find the x-intercepts. How do we work that problem? What happens to this -1 that's in front? Can't add it. What's going on between all three of these things? They're multiplying, right? So to get rid of the -1, I divide by it. So that I get x plus 5 times x minus 3. So really, that number that's in front, does it have anything to do with the problem as far as the x-intercepts go? No. Then I set each factor equal to 0 and solve it. So our x-intercepts are at -5, 0, and 3, 0. Set each factor equal to 0. You got it. Super quick and easy to get the x-intercepts. Okay, so that's the luxury of intercept form, is that the x-intercepts, you don't have to do much work. You just set the factors equal to 0 and solve. Okay. Now, let's go back and get the axis of symmetry and the vertex, which is not quite as easy from intercept form, but it is fairly easy from standard form. Could we take this intercept form problem and put it in standard form? Yeah, all we got to do is just multiply it out, right? So if I multiplied out x times x, or x plus 5 times x minus 3, and then it's got the negative on it, so that'd be x squared minus 3x plus 5x minus 15, and then simplify that, and then distribute the negative, so we have -x squared minus 2x plus 15. Now we've taken something that was in intercept form and we've written it in standard form. Now all the shortcuts and the easy things that we had from standard form, we can use here with this problem, even though they gave it to us in intercept form. Okay, one of the kind of pillars of being a mathematician is taking something that looks like something else and turning it into something you know how to work with. Taking a problem and manipulating it so that it looks like something you already knew how to do. So that's what we're doing here. So we're taking an intercept form and making it standard form so that we can use this little quick formula, -b/2a, to get the axis of symmetry, which would be +2 over 2 times -1, which would be -1. So the axis of symmetry is x equals -1. What does that mean about the vertex? It will be a maximum. What do we know about the ordered pair? It's the x value, -1, as it's going to be the same as the axis of symmetry every time. Okay. Next thing is to find the y value of the vertex. How do we do that? Plug it in for the x in the problem. Does it matter which form I plug into? No. I'm going to use the calculator to help me here just because it's a new tool and I want to try to learn to use it. So I'm going to type in the original problem in intercept form. So negative sign, parentheses, x plus 5, close parentheses, open up another set, x minus 3, close the parentheses. And now I want to hit second graph, and I'm going to type in -1 for the x. And it gives me the y value, 16. If I had typed in the standard form, -x squared plus 2x, or wait, minus 2x plus 15, and then went to the table, notice y1 is the intercept form y2 is the standard form. They got the same y value when I have the same x value in there. That tells me, hey, I multiplied it out the right way. Okay, because it should be the same. Okay. No, you really don't have to put both of them in there. I just did that to show you that they are the same. Okay, now, intercepts, we've already found the x-intercepts. What about y-intercept? I got the shortcut from the standard form. What is the y-intercept? 15, 0, 15. That's nice. And then now I can make my table. What goes in the middle of the table? Vertex, which was -1, 16. And I'm going to pick two x values to the left. To the left, -1 be -2, -3. And to the right be 0 and 1. I'll go to my calculator, second graph, and I'm just going to type those in. -3, -2, -1, 0, +1. 12, 15, 16, 15, 12. So I've got my ordered pairs that I can graph with. So on your coordinate plane, make sure you got plenty of room in the positive y direction. And plot those points. So I've got -3, +12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. -2, +15. -1, 16. That's my vertex. And then there's my y-intercept. There's my that. Where does it cross this x-axis at? Where should my graph cross the x-axis? We already found those. Look at the work we did. We found the x-intercepts, right? -5 and +3. If I go to -5 and +3, my parabola then goes through those. We had x-intercepts. The first example we did, it only had that one x-intercept. It was where the vertex was, so we saw where it was hitting the x-axis. Not every quadratic will hit the x-axis, but if you got x-intercepts and you're drawing the graph, it is helpful to plot those on the graph, unless they're just like way out there away from the origin. Most of ours should be. You get the nice picture. If we're unsure if that's correct, we just hit graph with our calculator, and we see it crossing here at -5 and +3. We don't see the top there. If I wanted to, I could hit zoom out. Just hit enter there, and we'd see that picture showing up there. Just hitting zoom out. And if I want back to the normal window, hit zoom 6. On the zoom out, you got to hit enter after you hit zoom out, because it'll zoom out from the origin here. All right. So standard form, intercept form. Intercept form has some shortcuts for x-intercepts. Standard form has a shortcut for y-intercept. The next form has a shortcut for the vertex and axis of symmetry. It's called vertex form. Let's talk about vertex form. F of x equals a parentheses x minus h squared plus k. Vertex form has a squared factor there in the middle, and the h and the k are your vertex. It's always the opposite of what's inside the parentheses. So if it's -4, the h value is going to be +4. If it's +6, the H value is going to be -6. You can always take the opposite of the stuff inside the parentheses, but leave the stuff that's on the outside the same. Okay. All right. So vertex form, it's got the vertex written in it there. And we know the relationship between the vertex and the axis of symmetry is that the x value of the vertex and the axis of symmetry are the same number. So we get two things with a shortcut from this method, which is nice. All right. And it's actually pretty nice when it goes to finding the x-intercepts too. So let's look at an example of one that's given to us in vertex form. 2 parentheses x minus 3 squared. Let's do minus, or let's do plus 5. Let's do that, plus 5. That way it makes sense a little bit different. All right, so it's in vertex form. This is H, this is K. That's what we got to know. We got to know that about vertex form. So with that, that helps us to do the axis of symmetry. I'm just going to abbreviate that, axis of sim to vertex. Should be no calculation required for either of these. The vertex, 3, 5. The opposite of what's on the inside of the parentheses, so that's a -3. So that's going to be a +3. Then the same as the stuff on the outside, so a +5, that's going to be a +5. That automatically means that the axis of symmetry is x equals what? 3. We get those two things for free if it's in vertex form. So vertex form is really handy when it comes to that stuff, especially if you're looking for a maximum or a minimum. Which one would this be? A minimum, because A is positive, right? Okay. We get into word problems, and it can help us to know what they're asking for. All right, third thing is the x-intercepts. So let's look at that one for this one. How do you find the x-intercepts? You set the problem equal to 0. So we're going to set 2 parentheses x minus 3 squared plus 5 equal to 0. And this is where knowing how to solve quadratics by different methods comes in handy. Because now I got to solve this thing. What would be the most efficient method for solving this problem? No, we've been 2 days without coming to school. Quadratic formula? No, it's not in the right form for that. Square roots? How would we solve it by square roots? Get the squared part by itself. That's the key phrase there. So there's the squared part. We want to get that by itself. So we would subtract 5. And then divide by 2. And now what? Take the square root of both sides. Plus or minus on the number side. So there's x minus 3. Plus or minus. What happens when you have the square root of a negative? It's an I, it's going to come out. Technically, you got square root of 5 over square root of 2. We're just going to leave it like that for this problem. Square root of 5 halves. And if I wanted to get x by itself, I'd add 3. So it'd be x equals 3 plus or minus I square root of 5 over 2. Complex solutions is what we have here. When we have complex solutions, that means that there are no x-intercepts. We can find the solutions to the problem, but on the graph, this thing will not cross the x-axis because the answers were complex. That happens if you're in vertex form. That can happen if you're in standard form. You could discover that through quadratic formula, where you would see that happening at. If it's in intercept form, it's not likely that you got complex. They're probably not going to give you complex factors in this particular level of stuff we're doing. When we get into higher degree polynomials, we'll talk about how we can build a polynomial from complex factors. But no x-intercept. So this thing does not cross the x-axis. If you graph it, you hit y equals and then 2 parentheses x minus 3 squared plus 5. You hit graph. We see there's the parabola, and notice it does not cross the x-axis. Anytime you got complex, you know you don't have any x-intercepts. You can't have a y-intercept, though. So let's find the y-intercept. How do we find the y-intercept? Plug what in for x? 0. And work that out. So the y-intercept is at 0, 23. If we look at the graph, that kind of makes sense. Notice it's going up and to the left kind of slowly there. If I hit second graph and typed in 0 for x, I get a 23. So that means I did the math right when I did it by hand. Okay. Not saying you have to use a calculator to do this, but I'm not saying you have to do it by hand either. Okay, so do what's best for you. I'm about the same speed either way. Okay. All right, let's make a table so we can draw the graph. What goes in the middle of the table? 3, 5. To the left of 3 would be 2 and 1. To the right of 3 would be 4 and 5. And I'm going to use my calculator to help me make that table. 1, 2, 3, 4, 5. So 13, 7, 5, 7, 13. 13, 7, 7, 13. That's right. Yeah. So draw yourself a graph. Make sure you got plenty of room in the positive y-axis direction. The only time you have to put numbers on your graph, like as far as what the blocks, if you change the scale and maybe you went by 2s or something like that on either the x or the y-axis, then you need to put marks and tell what numbers are there. But other than that, you probably don't have to. 2, 3, 1, 2, 3, 4, 5, 6. 2, 7. 3, 5. It looks like that. Graphing that parabola. All right. So graphing parabolas, finding all those things, and being able to draw the graph out of that. You got a graphing calculator that can help you out a lot. That's going to be handy. All right. You'll need regular paper for the next thing. I'll try to scoot through these and get you what you need out of that. All right. So lesson 21 is converting quadratics to vertex form. All right, when we're converting quadratics to vertex form, it's helpful to have a quadratic in vertex form because it means it's easy to look at the equation and see what the vertex is, which would be the maximum or minimum value. That's handy in context of a real life situation or application of quadratics. But it's also handy when you, a lot of you guys are like doubling up on math and stuff. So you're most likely the folks that are going to be taking pre-cal in the next couple of years, okay? And in pre-cal, you deal with these other conic sections, and you've got to be able to manipulate a problem and turn it into the right form. And part of doing that is using complete the square to convert from standard form of a quadratic into vertex form. If you can do that part, it makes doing things for circles or an ellipse or a hyperbola or those sort of different conic sections makes it easier to do. So we'll start with the easy one in Algebra 2 here with the quadratics, and we're going to convert using complete the square. So this is where we're going to use some of the things we've done before. So let's just start with an example. We'll start with one that's fairly simple. It's x squared plus 10x minus 6. And I'm going to take you through the process of completing the square to rewrite this in vertex form. Okay. Now, what you want to do, the first thing you want to do is kind of separate it with the a and the b term together, and then move the c out to the side. So we've just rearranged the problem so that a and b are in the parentheses, and then the c is on the outside of that. That's all I've done so far. Okay. The next thing that you would do is you would look at in front of x squared and see if there was a number in front of that. If there were a number in front of that, you would need to factor it out of the parentheses part, not the c part. We'll do some examples with those in there as well so you can see that. But you want to factor it out if it's there. There's not anything there for this one, so this makes this one a lot easier. Okay. So when we did complete the square, what was the next thing that we did? Half of the b value, which is the half of 10 on this case. So that'd be positive 5. So we're going to add 5 squared on the inside of the parentheses. If I'm adding 5 squared here, what do I do out here to keep the problem the same? I'm going to have to subtract that amount so that it equals the same thing. Because if I add something to a problem, it changes it. So I've got to subtract it back away. Okay? So I'm always going to add inside, subtract on outside. Okay? What does it make this parentheses factor as? X plus half a b. And then all I've got to do now is work out this little arithmetic problem. -6 minus 5 squared. So -6 minus 25 would be -31. And there we have a quadratic in vertex form. Takes a little practice. We're going to do some practice at this, but it just takes a little practice to get there. Okay. Again, you're always going to add on the inside, subtract on the outside with that half a b squared. Okay. Let's look at one that has a number in the front. So f of x is equal to 3x squared minus 12x plus 7. Okay. So there's the original problem. I'm going to separate it. I've got the a and the b in parentheses. I got the c on the outside separate. Okay. The next thing I want to do is factor out the number that's in front of x squared. I'm not taking the full GCF here because I don't need to take the x squared out of it. I just need the number. So I'm going to pull that number out to the front. Now I'm going to take half a b. What's half a b? -2. So I'm going to add -2 squared. But on the outside, I've got to subtract. But what did I really add over here? I didn't just add -2 squared. I added -2 squared that was inside of parentheses that was multiplied by 3. So I really added 3 times negative 2 squared. So I've got to subtract away 3 times negative 2 squared. Whatever I factored out to the front, that's got to be right there. It has to be there. If it's not, then it's not going to keep the equation equal. Because what we're doing here is we're taking this problem and we're going to convert it into vertex form. They should make the same graph when I get done. Okay? So that's why I've got to have that 3 out there. So I just need to work this out. The left-hand, the parentheses part, I've completed the square on that. So that means it factors x minus 2 squared. X plus half of b. Half of b was negative 2, so that's x minus 2. Over here, I just need to work that out. So that's going to be 3 times 4, which is 12. So 7 minus 12 would be negative 5. This turns into 12. That's where I'm getting that from. 7 minus 12 is negative 5. Now I've got that in vertex form. If I were to take my calculator, just to prove that these are the same, and on the y1, I'm going to type in 3x squared minus 12x plus 7. And then on y2, I'm going to type in that vertex form, 3 parentheses x minus 2 squared minus 5. And I hit graph. There's the first one. The second one landed right on top of it. There's no way that that's a coincidence. Okay. That's how you can check to make sure your vertex form and your original form are the same. Graph both of them. They should be the same graph, exactly the same. You shouldn't see 2 different graphs on there. Okay. Mine, a little tougher to tell because I got the blue and the red. They're just landing on top of each other there. But that's what's happening, is you're getting the same graph back from that. So there is our vertex form. What would the vertex of that graph be? Not negative 2. Remember, it's the opposite of the parentheses. Positive 2, negative 5. Always take the opposite of the parentheses. So positive 2, negative 5 is the vertex of that. All right, let's look at another one. Let's say we had f of x is equal to negative 5x squared plus 30x minus 13. So there's our original problem in standard form to start off with so far. So I'm going to separate it. What's the next step? Pull out that negative 5. So that's going to be negative 5 parentheses x squared. And then what do I get when I take a negative 5 out of a positive 30? Negative 6x. All right, half of b squared. What's half of b? Negative 3. So I'm adding negative 3 squared. What do I subtract on the outside? Again, this negative 5 is the negative 5 from the front. Okay, whatever you pulled out to the front, it's got to be there. On the very first problem we did, we pulled out a 1 technically, so there was a 1 there. But now the factoring's easy right here. We get negative 5 parentheses x minus 3 squared. And now I need to work this part out here. So I got negative 13 minus, that'd be 9 times negative 5 is negative 45. So what's negative 13 minus negative 45? Positive 32. And there we have a problem in vertex form from standard form. I want to think there was one of these on the benchmark. I know this will show up on the end of course test. It always does. Okay. Being able to rewrite there. All right, so there if we had a number in the front. What if we had a number in the front, but it was like this? So I'm just renaming the function g of x instead of f of x because I'm tired of f's. What's different about this problem from the last two that we've done? The number, well, is the number in front going to be a fraction, or what do we notice about these two terms? They don't have a common factor, right? So that's where the fraction idea comes from, okay? On the last couple we've done, that these two numbers had something in common, so that's what we were pulling out. These, when you separate that, the 2x squared minus 5x, and then the plus 11 over here, when you go to pull that number out, you're pulling out a 2 because it's the number in front of x squared. What's left right here? Negative 5 over 2. Good, man. Now, here's where it gets difficult for most of us. When we got that fraction thrown in there, we've got to take half of b and square it. What's half of negative 5 over 2? Yes. Half of negative 5 over 2 would be negative 5 over 4. So I'm taking plus negative 5 over 4 squared. On the outside, I'm going to subtract 2 times negative 5 over 4 squared. Remember that 2 comes from this 2 that we pulled out here. Two parentheses x minus 5 over 4 squared. And then we got to work that out. So negative 5 over 4 squared times 2. And then got 11 minus that. Math, enter. 63 over 8 plus 63. Why is the negative 5 over 4 squared? It's minus 5 over. This is half of b. And to complete the square, you take half of b and square it and add it to that. So over here we got to take that same amount and subtract it off. It's actually negative 5 over 4 squared times 2 that we added. So we had to subtract off 2 times negative 5 over 4. You're always going to have that squared value right there. Now this is the factored form of that. Okay. And it's always x plus half of b. So half of b is the negative 5 over 4. So that's what that is. Not incredibly, there won't be a ton of them like that. You'll see more like the first 3 that we've done there, but there are a few of those that come up. Let's look at one like this. Say we had x plus 7 and x minus 11. What form is that in? Factored form, also known as intercept form. Both of those mean the same things, right? So completing the square on that, impossible, right? So what form do I need to put it in? Standard form. If I put it in standard form, then I'm back to where I've been for the last 4 problems. So let's put that into standard form. X times x is x squared minus 11x plus 7x minus 77. So that's going to be x squared minus 4x minus 77. Now I can set this thing up to do complete the square. What's half of b? -2. So I'm going to add -2 squared on the inside. On the outside, I'll subtract -2 squared. What's my factored form on the parentheses? X minus 2. And then on the outside, I've got -77 minus 4, which would be -81. There's our factor or vertex form of that. Last one. Let's put a number out there in the front. What does that change about the problem? What do I still need to put that equation in? I still need to put it in standard form. That doesn't change. Everything's the same there, okay? So we're putting that problem in standard form, so we multiply out the x minus, or x plus 5 and x plus 9 together. We got the -2 parentheses x squared plus 14x plus 45. And then that's not quite standard form. If I went ahead and multiplied it out to 2x squared minus 28x minus 90, that would get us to standard form, completely to standard form. So now we're in standard form, and I can set it up to complete the square on. What should I do next? Pull out a -2. That's going to give us x squared plus 14x. It's familiar. It's what we already had in the step above the purple there in the blue. Now what? Plus 7 squared. What am I subtracting? -2 times the 7 squared, which we know is 49. So that's -2 parentheses x plus 7. We got 90 minus -98, which would be -90 minus -98 is -90 plus 98, which is +8. There is our value in vertex form of that. So converting from standard form and intercept form into vertex form. So being able to move between all of the different forms of quadratics is a good algebra skill, handy to do. All right, so